So for this next unit, we are going to be looking at three-dimensional figures now, not just two-dimensional figures as we were in the last unit. And we are going to be looking at surface area and volume of these three-dimensional figures. So the first figure that we're going to look at is prisms, so rectangular prisms or triangular prisms, any type of prism. And we are going to look at surface area first. So surface area, when you think about surface area, you are looking at the area of all of the surfaces of the object. So it's going to be multiple areas of this three-dimensional object. So on the Keystone formula sheet that we've already been referring to, there are surface area and volume formulas listed there. So this is the first one. This is a rectangular prism, and it has a surface area formula of this. So 2 times the length and the width plus 2 times the length times the height plus 2 times the width times the height. So this formula only works for rectangular prisms. We are also going to be looking at some other prisms, and this formula is not found on your formula sheet. This is the surface area of any other prism. So for example, the one pictured here is a triangular prism. And in order to find its surface area, you're going to take 2 times the base areas, where the bases are not rectangles. So 2 times the area of these two triangles that we're seeing in this picture, plus the perimeter of the base, so this triangle, times the overall height of the prism. So like if the triangles are my bases, the height of the prism is going to be along the side here. And I'll point that out as we go through the examples. So let's look at the first example. This first example is just a rectangular prism. So we're going to use that surface area formula that is given on our formula sheet. 2 length times width plus 2 length times height plus 2 width times height. So I'm going to go along with that other picture that we saw, and I'm just going to say that this square facing the front is like the base of our prism. And so this 12 would serve as the height, and then length and width. And the length and width doesn't really matter if you get that switched for this rectangular prism. Okay, now I'm going to substitute all these in. So 2, 6 times 6 plus 2, 6 times 12 plus 2, 6 times 12. And now we're going to multiply everything and then add them all together. So I get 72 plus 144 plus 144. Add it all together, I get a surface area of 360 square centimeters. And since we're still looking at area, surface area, it's still measured in square units, or in this case, square centimeters. So really what that 360 is telling me is that if I took the area of all the figures on this three-dimensional object, that's what the area would be, okay? Let's look at a triangular prism. So this is a triangular prism. So that means we're going to be using our surface area formula of 2 base areas. Anytime you see me use a capital B, that's referring to base area, plus perimeter, capital P, and then height of the prism. So if I look at this prism, my base is, I'm just making it a different color here, the base is this triangle. So that means 10 is serving as the height of the prism, not to be confused with the height of the triangle. So now let's take a look at actually solving for some of these pieces. So let's look at base area first. So base area, this area is a triangle. So area of that triangle is 1/2 base times height. So 1/2, the base of the triangle is 12, and the height of the triangle is 8. And so that gives me a base area of 48 square units. Okay, so that we'll be able to substitute into our formula here in a second. Next thing that I want to look at, though, before we start substituting in, is the perimeter. So I'm looking at the perimeter of this base, of this triangle. Well, we have the 12, but we don't know these two other sides. In order to find that, you're going to use Pythagorean theorem. Okay, this would be 6. So using 6 and 8, if you go through Pythagorean theorem, I'm not going to write it down, but 6 squared plus 8 squared, 6 squared plus 8 squared gives me 100, and then the square root of 100, this would measure 10, and this would measure 10. So my overall perimeter would be 10 plus 10 plus 12, giving me a perimeter on this base of 32. Okay, now we can kind of start subbing stuff in to our surface area formula. So 2 times 48 plus this perimeter of 32 times the prism height of 10. And if I multiply those, add them together, I get that the overall surface area is 416 square units. Okay, and this formula should kind of make sense. 2 of these base areas, and then if I take this whole perimeter times that height, it gives me all those rectangles along the side. All right, let's keep going. So I have another triangular prism. That triangle in the front is kind of like my base, and that 15 inches then will serve as my height. I'm going to be using my surface area formula of 2 base area plus perimeter height. So now let's take a look at this base area first. Again, it's a triangle, so 1/2 base times height. Okay, so this is an equilateral triangle. That 8 kind of goes here. So we still need to find the height of this equilateral triangle, which we've been doing already, in order to help us calculate this base area. So this would be 4, this would be 4, this would be like a 30, 60, 90 triangle. And so using the 30, 60, 90 rules, this height would be 4 square root of 3. So just to review that a little bit, but we have been finding we've been finding area of equilateral triangles too already. So 1/2, the base of this triangle is 8, and then the height we just found was 4 square root of 3. I'm going to leave this as an exact answer for when I substitute. So 1/2 of 8 is 4, and 4 times 4 is 16. So the base area of this prism is 16 square root of 3 square inches. And so I'm going to substitute that in later. Let's just figure out what the perimeter would be. 8 plus 8 plus 8. That's going to give me a perimeter of 24 inches. And now I can substitute everything in. So surface area 2 times this base area of 16 square root of 3 plus this perimeter of 24 times the height of 15. So now I'm going to multiply everything, add it together. I'm going to round my final answer to the nearest tenth, so you don't have to worry about giving your answer in terms of a radical. Put it into your calculator, nearest tenth. This is going to give me a surface area of 415.4 square inches for the surface area. Okay, and last example, again, we have a triangular prism. This time the prism is situated a little differently. It's actually sitting on its base. So both of these triangles are serving as the base still, meaning now that this 8 millimeters is actually the height of our prism. Okay, so the base is this right triangle. I'm just going to redraw it. That has a base of 10 and a height of 15. So that's going to be important when we find its area. So surface area, 2 base area plus perimeter height. Let's look at the base area first. So 1/2 base times height, because it's a triangle again. So 1/2, the base is 10. The height is 15, giving me a base area of 75 square millimeters. And now let's look at the perimeter too. So I already have the 10 plus the 15, but I do need to figure out what the other side or the hypotenuse is to help me figure out the perimeter. That's going to be Pythagorean theorem again. And so I would do 15 squared plus 10 squared, take the square root of that and simplify. I'm going to let you guys do that. You get 5 square root of 3. 5 square root of 3. And when I substitute this in this case, with this addition, I am going to go ahead and round it, but I'm going to round it to the nearest hundredth for when I substitute it in, and then I'll round my final answer to the nearest tenth. So if I add all these together for my perimeter, I should get 33.66, and that would be millimeters. And now I'm ready to substitute in. So 275 was my base area, plus this perimeter of 33.66, and the height of my prism was 8. So I end up with a surface area of 419.3 square millimeters. Okay, and that's all for surface area of prisms. Next we will do volume.